Today in the Backyard Solar Project, we have an early test unit of the Bluetti Apex 300. This is a unique power station because of its built-in 240-volt output. I'm going to cover three things that I tested with the Apex 300, the first being that 240-volt power output, and how it worked and didn't work with my heating and air conditioning unit. Next, I'm going to talk about the runtime of the Apex 300, especially when powering a small AC load. And I'm going to compare those runtime numbers to previous Bluetti products. I think you'll be surprised with the results. Finally, I'm going to talk about the solar inputs on the Apex 300 and how I connected them in different ways to my 300-watt solar panels. Let's get started. Before we get started, let's take a quick look at the 240-volt receptacle. One Apex 300 is capable of outputting 3,840 watts. In 240-volt mode, this works out to 16 amps. If you are trying to figure out if your 240-volt appliance will work with a single Apex 300, it is important to keep those numbers in mind. Most appliances will list their power requirements on a label. For example, here is the label for my heating and air conditioning unit. There are a lot of different numbers listed, but I'll outline the ones that are relevant for this test. First, at 230 volts, the cooling side of this unit runs at 6.2 amps, 1420 watts. Next, also at 230 volts, the heating side of this unit consumes 5,050 watts. This particular company does make units that require less heating power, but more about that later. Based on the relevant heating and cooling numbers, I would expect the Apex 300 to be able to handle this unit in cooling mode, but not have enough output for heating. Let's test it out. Before we can connect the HVAC to the Bluetti, we have to have the appropriate cable. In this case, I needed a 630 receptacle for the HVAC on one end, and a 1450 plug on the other end to connect to the Bluetti. There are many different 240-volt plugs and receptacles. Be sure to check out what you have well before you need to make a connection. Once it was all connected, I started with the air conditioning. After adjusting the thermostat to turn on, the Bluetti ran the AC without any problems. I pulled up the app to monitor as well. Peak output was around 1100 watts, with the power split evenly across L1 and L2. This went as expected, since the air conditioner requirements are within the output specs of the Apex 300. Now, onto the heating side of the unit. Turning on the heating element resulted in the Apex 300 starting to provide power, then shutting down when the pull from the heater was too high. The Bluetti's overcurrent protection did its job, and a quick reset of the unit had it back to normal. Clearly, the heater's requirements are too high for a single Apex 300. If you recall earlier, I mentioned that there are models that use less power. Strangely, they listed the requirements of those lower output models on my unit's label. It's too bad I don't have one of the smaller ones, because both of them consume less than 3,800 watts. If you've watched other runtime videos on this channel, you know that I always take the same approach. I run a low wattage AC device until the power station shuts off. For consistency, I've always used this exact 60-watt light bulb that consumes an average of 58 watts. That's just about the same amount of energy used by my refrigerator and cable modem, so it's a good indicator of what I might be running in an unexpected power outage situation. Prior to starting the test, I did a full empty and recharge of the Apex 300. Next, I connected a watt meter between the light bulb and the Bluetti to monitor the power output and total energy used. Finally, noting the time, I turned on the light bulb. Letting these tests run until the station shuts off can take some time. In this case, it took over 35 hours. By the end, the Apex 300 ran for 35.2 hours and output 2,035 watt hours. Compared to previous tests of the AC300 with the B300 and B300K batteries, the Apex ran significantly longer. The AC300 ran for 31.8 hours with the B300 battery and 30.3 hours with the B300K battery. Overall, the Apex 300 showed a 10 to 15% improvement. On the screen, you can see the total watt-hour differences as well. I was impressed by this extra runtime from the Apex 300. I would presume the extra performance is due to better inverter efficiency versus the older AC300. Now let's move on to the solar inputs on the Apex 300. First off, actually connecting solar panels to the Apex 300 is fairly easy. However, it's important to note that Bluetti is not currently including the solar connection cables, so be sure that you order your PV cables separately. Now, onto the unit. There are two PV inputs on the right-hand side of the Apex 300. Both of them can handle up to 1,200 watts of panels, with a maximum of 60 volts per input. As the math would suggest, each input therefore tops out at 20 amps. If you're familiar with other power stations, you'll immediately realize that a 60 volt maximum is going to make it tricky to hit 1,200 watts of solar on one of these inputs. My fixed array is made up of 3 panels at 310 watts each for a total of 930 watts. However, each panel's voltage at max power is 33.1 volts. So with 3 of them in series, I'm over 99 volts, well above the 60 volt maximum of the Apex 300. I'm not an expert in connecting panels, but I know that you do not want to exceed the voltage of your system, as it can cause damage. But exceeding voltage doesn't just stop at 3 panels in series. Based on their specs, even 2 of my panels wired in series can exceed the max voltage of the Apex 300. Those 2 panels would reach 66.2 volts at max power. Yes, it would only be 620 watts, but the voltage is too high. Since series connections are potentially problematic, let's look at some other options. This is a good time to note that on a Bluetti, it's okay to somewhat go over the amp limit, but not okay to go over the voltage limit. In series, the voltage adds up. In parallel, the amps add up. In the case of the Apex 300, exceeding the amperage just means that you won't be getting any additional power after you hit 20 amps. So, what if we connect panels in parallel? Wired in parallel, 2 panels would give me 620 watts on one input and would be under 20 amps, so power wouldn't be clipped. This seems like a good start. Another option would be to connect 3 panels in parallel. In this case, the panels could output as much as 930 watts. But because in parallel the amps add up, I would be dealing with 28.1 amps. Since the Bluetti can only use 20 amps, the potential watts would be clipped at 662. Let's test out these 2 scenarios, starting with 2 panels. Connecting in parallel requires, you guessed it, parallel connectors. I recommend getting some. They are handy to have, and regardless of your setup, you'll never know when you might need them. I disconnected my array and wired up the right 2 panels in parallel and connected them to the Apex 300. The sun wasn't perfect, but I was able to get 551 watts of power at 27.1 volts. This definitely worked. Next, I tried connecting 3 panels in parallel. Please note that I am not recommending that you try this, as the amps really start to add up. However, I wanted to see the results and see if they matched our predictions. After connecting the 3 panels up, using 2 sets of parallel connectors, here's the result. And again, the sun wasn't perfect. The most I was able to get out of the 3 panels in parallel was 602 watts at 29.1 volts. Doing the math, that suggests the Apex 300 was pulling just about 20.7 amps. Given that the 2-panel setup was producing 551 watts in similar sunlight, it is reasonable to assume that this 3-panel setup would have hit 825 watts. However, due to the amperage limitations, the Bluetti was clipping power at 602 watts. With this in mind, I would stick to only 2 panels in parallel. So, what does all of this mean? If you want to get the most from the solar inputs on the Apex 300, you'll likely want 2 very large panels connected in parallel for each input. Certain 5 to 600 watt panels may be compatible. Just be sure to double check all the specs, especially the voltage, to ensure that they are safe for your location and wintertime temperatures. With the right large panels, it seems possible to hit 900 to 1,000 watts on each of the Apex 300 solar inputs. However, hitting 1,200 watts is going to be a stretch. To get more solar charging with the Apex 300, I recommend taking a look at something like the upcoming SolarX 4K accessory. That device should accommodate a lot more panels and higher voltage. Well, that's about all I have for today. I hope this look at 3 different aspects of the Apex 300 was helpful. As always, thanks for watching.